Thank you. I feel like after listening to these last presentations, I'm kind of going back in time to the 1980s and 1990s, and I am actually retired. So this is why I include this little picture of myself in front of Mount Rushmore out near Rapid City, South Dakota. But I'm also involved in several small companies, and I'm an advisory editor for Elsevier in book publishing, and I'll mention a few of our recent books on the last slide. So what I've done is I've taken a biomimicry 3.8 biomimicry tool, and I've kind of created this faux flower that talks about some biomimicry paradigms that can be sort of used to measure the utility of some technologies that were developed in part by with using nanotechnology. So let me go ahead and talk about several of those. The first actually is something we started, a program we started for and continued for many years to develop a single source precursor approach to making materials at lower temperature and enable us to use flexible, lightweight substrates, low temperature substrates such as polymers and metal foils. And this eventually led to a commercial product has been sold for about 10 years by a company called Nanotech Innovations. Another topic I'm going to delve into is the notion of integrated power technologies, combining solar cells and batteries into one device. And in fact, we managed to get some data out of a small sat called Starshine 3 about 10 years ago. And I'm going to talk a little bit about the CubeSats, which is sort of the next generation. And then eventually at the end, I'll talk about in situ resource utilization. And this all really starts at the dawn of the space age when John Kennedy became president. And a statement he made in a famous speech he gave during his acceptance of the Democratic Party's nomination of president. And he said that the new frontier of which I speak is not a set of promises, it is a set of challenges. And 30 years later, Dan Golden sort of illuminated what some of those challenges would be. And he determined that in order for NASA to be a viable institution going forward, we needed to develop technologies faster, that work better, and were less expensive. So we'll talk a little bit about that. So single source precursors were actually, that we developed, were actually a family of molecules that have various parts that are, let's say they're modular. And because they're engineered single sources, it required much less energy to deposit. This is actually just a little picture of an example of our thin film solar cell. This is copper indium disulfide, but they're a family of chalcopyrite solar cell materials. This is actually sort of a tinker toy reactor that we developed. And that reactor was eventually made foolproof and has now been manufactured and sold by a company in Oberlin, Ohio called Nanotech Innovations. Nanotech has since spun off a company called Core Water Technologies. And the point of Core Water Technologies is to help develop nanotechnology solutions to remove so-called forever chemicals from water. And those forever chemicals are the water equivalent of chlorofluorocarbons, which were destroying the ozone layer and still do, but to a much lesser extent. Let me talk about the integrated power technologies that were developed. So one manifestation or one device structure that can be used for photovoltaics is a dual junction or multi-junction device. If this multi-junction device was now, instead of two solar cells, a battery and a solar cell, we make something called an integrated power source. The integrated power source that was tested on the Starshine 3 that was launched in late 2001 actually gave us data. And as far as I know, this is the only time that a single source precursor inspired technology, which is this integrated power source, was actually tested in space. And it turns out that albedo light reflected off the surface of the Earth, can actually be used to recharge recharge batteries via solar cells. This data is from batteries that were recharged by solar cells directly illuminated by the sun. And so this is where we point to the integrated multifunctional nature of these devices and the fact that they're nested. So let me, I'm starting to wrap up. I've got a few slides left. Let me talk about a very interesting and successful CubeSat mission that occurred a few years ago. This is called Marco. So Marco is actually 2 CubeSats that were launched alongside a Mars mission, and they successfully demonstrated communication enabling from the surface of Mars to the Earth. This is actually a picture that was taken, the last picture that was taken by Marco as it was leaving Mars. And again, this is a modular nested system. We've heard some things about living off the Earth and future exploration. This is where in situ resource utilization comes in. This is a resource efficient way to use local resources. This is actually a demonstration of a solar collector with a chemical processing unit to help break down the regolith of the moon. This was tested on a mountainside in Hawaii about 10 years ago. My role was to manage the production or the development of this system. This is a cartoon of how we would begin to develop a colony on the moon or Mars off the Earth. And again, this is an artist's conception of what we could eventually expect to develop to support a human settlement off the Earth. In this case, this is the moon. So I wanted to wrap up just mentioning the 5 books that have been published or will be published over these last few months. The 2 biomimicry books were published by Elsevier in late February. These nanomaterials via single source precursors, the main focus of my work for years, was published last month by Elsevier. Silicon anode systems for lithium-ion batteries was published in September, October of last year. And the book on lithium sulfur batteries is coming out next month.